from past papers and look at the types of questions. Sometimes it can be really difficult. So let us get straight into it and look at the questions. So we have a whole list of trial papers here that we can work with. So we start with the Western Cape paper and let's see. Okay, so before we do this, we need to just know what is AP and GP, the formulas and stuff. So in an arithmetic progression, we know the Tn formula. Tn is equal to A plus n minus 1d, or linear. And we know the Sn formula is n over 2 into 2a plus n minus 1 d. Sometimes it's written as n over 2 into a plus l, if you know the last term. And in a geometric progression, we have Tn, which is equals to a r to the power n minus 1. The sum to n terms is a r to the power n minus 1 over r minus 1. We can also use this formula. Okay, we use this formula when it diverges, when the numbers gets bigger and bigger and bigger. And for converging, we use 1 minus r to the power n divided by 1 minus r. We use this formula when the sequence of numbers gets smaller and smaller and smaller. Now, where's the interval for convergence divergence? When the value of r is between minus 1 and 1, we say the series converges and it diverges out of this interval when it is less than -1 or when it is more than 1. But the value of minus 1 and 1, it converges. So converges when the value of r is between minus 1 and 1, it converges, else it diverges. So if the series or if the series converges or the sequence of numbers converge, then we can find in the sum to infinity. Converges only works for sum to infinity. Sum to infinity is just a over 1 minus r. So if you're looking at your convergence formula, this part is basically out, r to the power n, because r to the power n eventually becomes 0 when it converges, okay? So that's basically, it's like taking a fraction and raising it to the power infinity, which becomes 0. So you just have a times 1, which is a over 1 minus r. So these are all the important formulas that you need to focus on. Right, now, let's look at these questions. Western Cape. The following arithmetic sequence is given by, so we have an arithmetic sequence. We can see we are adding 6 each time. So your common difference is 6. So first question, how many terms are there in the sequence? How many terms is Tn formula? Right, so Tn is equal to A, which is -7 plus n minus 1 d. D is 6. How we know d is 6? We are adding 6. See, from 5 minus minus 1, which is 6. Or -1 minus minus 7. -1 plus 7 is 6. And you can clearly see we are adding 6 every time. So that's your common difference, right? And this part here must be equated to 167. So what we can do now is, because we want to know how many terms are there, we are solving for n, right? So what we can do is we can take 167 add 7 divided by 6. So 167 plus 7 is 174. And we can divide it by 6, and then we can add 1. Right? So that's how you're going to get n. So therefore, n is now equals to all right, so therefore n is now equals to someone can do the calculation there quickly. Right, I just want to pop my calculator as well. Right, so we got 174 over 6 and add 1. Right, we get 30 terms. So we know how many terms there are by using the Tn formula. Calculate the value of n for which the sum will be 8,208. So calculate the value of n for which the sum will be. So again, the second one is also calculating Sn. Sn is n over 2 into a plus l. Right, so a plus l, because we already know what the last term is. Okay. And this sum must be equal to 8208. Now n over 2 into a plus l, that's n over 2. No, we can't use n over 2 into a plus l because we are not summing up this. We're summing up another sequence. So n over 2 into 2a plus n minus 1d. Right? Because we are solving for n. So n over 2 into 2a plus n minus 1 times d. So n over 2 remains n over 2. 2 times a is 2 times negative 7 plus n minus 1 times d is 6. And that's equals to 8208. Now we're going to solve this equation. Right, so I can take 8208 and multiply it by 2. So I have an n there. I got negative 14 plus 6n minus 6. Oh wait, we can leave the n over 2 there. Is equal to 8208, because if I take a half and multiply inside here, it might simplify. So still got n over 2 into 6n minus 20. Right, 6n minus 20 is equal to 8208. Right, so you will get 3n squared, because n over 2 times 6n is 3n squared. N over 2 times this is negative 10n, and bring this 8208 is equal to 0. Just 1 second, guys. You can try putting this onto the calculator and see what you get. 1 second. Where are you going now? All right, so let's do mode 5.4. Mode 5.4. So we have 3, negative 10, 8208. Why are we getting these fancy answers? Did I put negative 8208? Supposed to be putting, yeah, negative 8208. Negative 8208. Okay, so we get 54. So we're getting n minus 54, and we should get 3n plus something, and 3n plus 152. Right, so n is equal to 54, or n is equal to negative 152 over 3. So reject. Why are we rejecting? Because it's a fraction and it's negative. Remember, n is supposed to be an element of natural numbers, finding the number of terms. So accept here. So what's the answer here? Calculate the value of n. They only wanted the value of n, so n is equal to 54. And we will put this answer as our final answer. All right. Okay, you don't need to write accept. That's it. Okay, so let's have a look at the next question. Okay, so we have a nice problem here because this is based on what is this? A geometric sequence, because we can see we multiplying by from x, how do we get to x squared over 2? I think we're multiplying by x over 2 each time. So that's a common ratio. Determine the nth term in terms of x. How do we go about finding the nth term? You say Tn a times r to the power n minus 1. Right, so your value of a is x, the first term. Your common ratio is x over 2 to the power n minus 1, right? Determine the nth term in terms of x. So it is in terms of x. Remember how we found the common ratio. Common ratio is x squared over 2. And we're dividing it by term 1, which is x. So x squared over 2 multiplied by 1 over x. So that's how we get x over 2. That's a common ratio. That's it. Determine the values of x for which the series will converge. So when will the series converge? It will converge when the value of r is between -1 and 1. So this is how you start off converges. -1. Right, this is your formula for convergence. This is your inequality for convergence. And the value of r was x over 2. Okay. The value of r was x over 2 and it is less than 1. So now you can multiply everything by 2. So -2 to 2. Right. So the value of x must be between -2 and 2 in order for this to converge. In other words, the numbers will get smaller and smaller and smaller. If the sum of the first two terms is equal to 5 over 8, determine sum to infinity. That's easy, right? Sum to infinity we know that it is a over 1 minus r, and the first two terms is equal to 5 over 8. So x plus x squared over 2 is equal to 5 over 8. That's the first thing you must do. X plus x squared over 2. The sum of the first two terms, right? Term 1 plus term 2. So x plus x squared over 2 must be equal to 5 over 8. So solve for x. Right? And now we're going to do the LCD. So we are going to multiply everything by 8 here, right? LCD is 8, right? So 8x plus 8 times half is going to give me 4x squared here. And that's equals to 5. Make a quadratic and solve, right? So we're getting 4x squared plus 8x minus 5 is equal to 0. And now we can factor this out. Let's see. Mod 5, 3, 4, 8, and -5. 2x minus 1 or 2x plus 5 over 2. Yeah, 2x plus 5. Right, so x is equal to half or x is equal to 5/2. So we're going to reject this, right? So this is my answer. Now that's the value of x, which is half. And they told us the value of x must be positive, right? So if the value of x is half, let's take the answer back here now. If the value of x is half, right? What's the value of a? A is x, right? And that's half. What's the value of r? R is x/2. So x is half. So half divided by 2, you will get quarter. So therefore, the sum to infinity is a over 1 minus r. Value of a is half, right? And 1 minus r is quarter. So you got half divided by 3/4, which is times 4/3, right? So your final answer will be 2/3 because 4/2 is 2. 4 and the 2 cancel out, 2 times 2/3, right? So this is the calculation that you're going to show for 6 marks, right? Now, there's sigma notation as well. So I hope you understand what those sigma means. It's a counter. It counts from certain starting position to ending position, right? Now, look at the sigma. It's kind of like it's going to trick you here because they want to know the number. Okay, so because we're starting at, you're not starting from 1 to 20. Say count from 2 to 20. How many numbers are there? There'll be 19 numbers. If you count from 1 to 20, there will be 20 numbers. So, but how do you find the number of terms in a sigma? You say n is equal to last minus first plus 1. So last term is 20 minus the starting value is 2, add 1, you'll get 19 numbers. Calculate the first term of the series. The first term is a equals, you're just substituting 2 here. So the value of k is 2. So you're substituting 2 to the power. So it's just 2x minus 1 squared. That's your first term. For which values of x will this here exist? For which values of x will this entire series exist? How do we go about existence of the series? Okay, I'm going to expand this because remember, this is a higher order question, right? The way they have asked it is very high order. It's like level 4 type questions, right? You get different cognitive levels in math. And this is like a level 4 type question because see the way they have asked this question. Now, if you're going to open, the first thing I will do is open up this sequence. So to check what's happening. So I will say this is 2x minus 1, right? Squared plus 2x minus 1 cubed plus dot dot dot, right up to 2x minus 1 to the power 20. All right. So this is my expansion. If I try to find the common ratio here, I need to check something. If I work out the common ratio, what will I get? Common ratio. If I try to work out r, it's just 2x minus 1 cubed divided by 2x minus 1 squared. So that is just 2x minus 1. If I try to check for convergence, right? If I try and check for convergence, what about the convergence of this? When will the sequence converge? So I'll say 2x minus 1, put it between minus 1 and put it between 1. If I take the negative 1 over, you'll get 0 because I'm adding 1 and 2. If I divide everything by 2, so we know it converges between the interval 0 and 1. For example, if I put half, that's r, 2x minus 1. It converges between 0 and 1. Yes, guys. Which values of x will this here exist? What are they talking about here? They're talking about the sum of this entire thing. If I try to sum up 19 terms, what happens? Because when they say sigma, when will it exist? It will exist for all values of r except 1. Yeah, because the values of x can't be 0 and 1. Okay, let's see. Let me try summing up this. There are 19 terms here, so S19 is equal to what's the formula? You have to try out different techniques because I still don't have any restrictions for x because they want values of x when this here will exist. Can I choose any value of x? I can clearly not choose 1. For which values of x will this here exist? This is linear. These are all polynomial functions. So it can be any value of x. We don't have any denominators here, so it can't be undefined. See, if you're summing up all these terms here, then this is polynomial, that's polynomial, that's polynomial. Then it can be any value of x because you see every term. Okay, yeah. So you can say sum to the total sum. Total sum is a polynomial function. Total sum is a polynomial function, is a polynomial, right? Therefore, x is an element of real numbers. So I didn't need to do all this convergence. This one here, I was just checking what happens. They didn't ask for convergence, divergence. So it's all real numbers. I can choose any real number value here, right? I can choose any real numbers here to calculate the sum. All right, guys. Because see, if you sum up everything here, you'll just get a bigger polynomial. I can choose any value of x. A polynomial function is always continuing forever. You can choose the domain of polynomial function, like the domain of linear function is XER. The domain of quadratic function is XER. X is an element of real numbers. The domain of cubic function is X is an element of real numbers, right? So basically they are asking you for domain in this scenario. For which values of X will this sigma exist? So I would go with X is an element of real numbers. Right, so basically they're just asking you for a domain. Manage to understand this problem now. The domain. So domain is just X is an element of real numbers. Wow. Now coming to word problems, very important that we do these word problems, right? Because it has understanding in it. Right, let's see. Okay, so Tanya starts a fitness program by going, yeah, guys, any questions here? Mishka, we good? You understood this problem? Remember, each
Yes,
of
sir.
these, right? This was, I don't know why. If you just thought about it like this, then it would have been so much more easier. But you see, the way they asked this is like confusing. They're gonna take you in circles. Right, anyways, let's go to the next problem. Or now we good? You understand it? Right, so let us read
Yes,
the
sir.
next question. Right, excellent. Tanya starts a fitness program by going for a run on Saturday in the local park. On the first Saturday On the first Saturday, she runs 1 kilometer and plans to increase her distance by 0.75 kilometers every Saturday. So on the first Saturday, she runs 1 kilometer. Next Saturday, she runs 1 kilometer plus 0.75 kilometers, 1.75. So it's just increasing by 0.75 every Saturday or every week, okay? So it can't be geometric because we're not multiplying, we are adding by 0.75 every week. That's what they have said. She further decides that once she reaches the distance of 10 kilometers, she will continue to run 10 kilometers every week thereafter. So until she reaches 10 kilometers, then she will not increase her distance afterwards, okay? So your pattern is something like this. If you think about the pattern, so you're going to have 1.75, right? Then you're getting 1.75, so 2.5, right? Dot, dot, dot. And then she runs 10, and then 10, and then 10, and then she continues forever running 10, okay? Calculate the distance that Tanya will run on her ninth run, all right? So we want to calculate the term 9. Term 9 will be a plus n minus 1, which is 9 minus 1, 8d, right? That's term 9. Now, how we work this out is Tn is equal to a plus n minus 1d. So 9 minus 1 is 8. So I already minus 1 here. Instead of writing 9 minus 1, just write a plus 8d. So the first term is 1 plus 8, and the difference, common difference is 0.75. Right, so you can multiply this out and add them up. So 1 plus 8 times 0.75, I'm getting is 7 kilometers, all right? On her ninth run, right? So she runs 7 kilometers. Calculate the total distance that Tanya will run over the first 24 Saturdays. Now be careful because see how your pattern is, right? That's why I wrote down the pattern so you don't get confused. Now, most people, what they will do is they will go and find S24, which is totally incorrect. You can't go and find S24 because on her ninth run, she's running 7 kilometers, right? Now, after 7 kilometers, you know that is term 9. So see what happens now. I'm going to take this pattern out and put it here. Be careful. So this is like another level 3 type question. I wouldn't say level 4 because it doesn't have so much of thinking involved there. So we know on the ninth run, she's running 7 kilometers, okay? Seven kilometers is term 9. Right? That's term 9. Right, so what's term 10? 7.75, right? So term 9, in other words, to get 10 kilometers, she needs to run like another 4. So term 13 will give her 10. But we can solve for this, all right? You don't need to guess here. So we're going to say Tn, when up to until which Saturday will she be running 10 kilometers and then stay constant afterwards? Right, so Tn is equal to a plus n minus 1 d is equal to 10. So let's check if it's actually term 13, all right? So a was 1 plus n minus 1 times 0.75 equals 10. So 10 minus 1 is 9, and then 9 divided by 0.75, right? And we're going to add 1. And that's how we solve for n. So n is equal to 9 divided by 0.75, right? 12, and then add 1/13th, right? Because remember how I worked this out was we're adding 0.75 until we get 13, right? So we know on the 13th run. So what is the sum to 13? So S24 will be sum to 13 terms plus, so summing up 1 to 13, and then sum to balance of the 13 terms, balance of the how many terms? We want S24. So what's 24 minus 13? 11, right? 11 terms, sum to 11 terms. Now S13 is summing up 13 terms from this sequence over here. Summing up all that. And S11 is summing up the balance here, right? So let's go S13. We're going to say, look, you can find the S12 and you can find the S12 as well if you want. But S12, remember, the 12th term is not 10. So you can find the S12 where you can group the 10 with 10 12s here, right? But S11 is easy. We can find S11. S11 is just 11 times 10, right? But S13, what's the SN formula? N over 2 into A plus L. So we know what's the first term and what's the last term. We know what's N. N is 13 over 2. A is 1. Plus the 13th term is 10. All right. And we can calculate the sum here. That is 6.5 times 11 plus 110. 11 times 10. Right. And then 6.5 times 11. I just need to work that out. Times 11 plus 110. I'm getting 181.5 kilometers. Okay. So that's my final answer. So just be careful how you are answering the question. Calculate the total distance that Tanya will run over the first 24 Saturdays. Right. Perfect, guys. Arnav, you understood this problem? We good?
Yes, sir.
Excellent. Guys, if you have any questions, please ask. Or if I'm making a mistake, please correct me. Right. Right, so nice word problem there. 3.2, a very good question, right? Moving on to the next question. Yeah, okay. Nice question here as well. This is from the Northwest Province paper. Right. Consider the following geometric series. Now, they gave us a geometric series. Remember what's a series? Series is in terms of plus, plus, plus. Sequence is with a semicolon. So it's just a sequence of numbers. Series, when they talk about series, it means it's a sum of numbers. Determine the value of P. It is geometric series. So we know in a geometric series that we have a common difference, common ratio. Common ratio is 63 divided by 21. Which is equals to 21 divided by P, right? 63 divided by 21, or you can check what's happening, how you went from 21 to 63. You multiplied by 3. So if you're going backwards, you're going to divide by 3, divide by 3. So the value of P is 7, all right? We can work it out like that. So the value of P is equal to 7. Anyways, let's do it like this as well. Oh, if I'm doing it like this, is such a complicated thing here. So 63 divided by 21 is 3. We got 21 divided by P. 3P is equal to 21. So P is equal to 7. So try to be smart and work it out with just like this. Just write down the answer. But they said determine the value of P. So you need to show some calculation. There's it here. Determine the number of terms in the series. It's a geometric, right? So what's the SN for a geometric? A r to the power n minus 1 over r minus 1. All right. Now let's fill in all the details. And that must be equal to 137,781. Now, what is A? A is 7. R, the common ratio is 3. Remember what we said? Common ratio is 3. There's it here. Which is 63 divided by 21 or 21 divided by 7. Common ratio is 3. And you can see this sequence of numbers is diverging. So 3 to the power n minus 1 divided by 3 minus 1 is equal to 137,781. All right, so now how we're going to solve this is we're going to multiply this by 2 and then divide it by 7. Multiply it by 2. 3 minus 1 is 2. So multiply and then divide by 7. All right. So you're going to say 3 to the power n minus 1 is equal to 137,781 multiplied by 3 minus 1, which is 2, and divided by 7. You're going to get this and then add 1 to it. So let me remove the minus 1 here and add 1. So what we have done, 137,781 multiplied by 2 divided by 7. So you will be left with 3 to the power n minus 1. So just add 1 here. So adding 1 will give me 39367. Now, if you want to solve for n, you can just use logs, or you can put this number in terms of base 3. So think about this is 3 to the power what? Maybe it's 3 to the power 6, or maybe 3 to the power 7. I don't know. 3 to the power 8. Let's try 8. Nope. Maybe 3 to the power 10. Still no. 3 to the power 11. That's going to, wait, supposed to be 19,683. 1 second. 2160. 137,781. 137,781 times 2 divided by 7, then add 1. Wait, I just want to double check my calculation. What if I try logs? Log base 3, 39367. Maybe I entered the values incorrectly. Determine the number of terms in the series. The value of A is 7. 3 minus 1 over 3 minus 1. That's fine. Again, let's see. 137. Wait, guys. This is incorrect, what I'm doing. I'm summing up all the terms to give me, it's not summing up the terms, it's Tn formula. That's why it's not working out. Sorry, guys. Supposed to be Tn. Tn is equal to A times R to the power n minus 1. That, not Sn, Tn must be equal to the last term. Remember, this is the term value. They didn't say the sum of everything is that. Yeah, so now we're on the right track. So A is A7, R is 3 to the power n minus 1 is equal to 137,781. Okay, so that's why that went off. Sorry about that. So 137,781 divided by 7, all right? 19,683. Right, so now we know 19,683 is 3 to the power 3 to the power 9. Yeah. So we can drop the bases now. And we can say n is equal to n minus 1 is equal to 9. Therefore, n is equal to 10. So there are 10 terms. Calculate the sum of the series. Now we come to the sum. Right, so Sn is a r to the power n minus 1 over r minus 1. So what we want to calculate is S10, the sum of all the numbers. S10 is a is 7, 3 to the power 10 minus 1 divided by 3 minus 1. Now you can calculate the sum of all these numbers. 7 into 3 to the power 10 minus 1 divided by 3 minus 1 is just 2, right? So I'm just going to put a 2 there. 206,668. Yeah, right. So that's your sum. That's how you would. So there was nothing difficult here. Straightforward problem. Okay. No difficult questions there. Maybe this one might be difficult. 6 marks. Try to draw diagrams and stuff, especially with these types of questions. A school hall is filling up at a rate of 10 learners in the first minute. 10 learners in the first minute, 14 learners in the second minute, and 18 learners in the third minute. So we got 10, 14, 18, and so on. How many learners will enter the school hall during the 8th minute? So this is a pattern, and it looks like 10, 14, 18. That is just, you can see the rate at which is filling up is we got 10, we got 14, and we got 18, and so on. So that's the first minute, that's the second minute, that's the third minute. Then the 8th minute will be T8, right? So we can see this is an arithmetic progression. So T8 is equal to A plus 7D. What's A? 10 plus 7 times, what's difference? 4. 28 plus 4 is 28 plus 10 is 38. 7 times 4 is 28. It's going to be 38 learners. How many learners? 38. Right? The school hall is a fifth full after 8 minutes. The school hall is fifth full after 8 minutes. After how many minutes will the school hall be full? Right? After how many minutes will the school hall be full? How are we going to solve this question now? The second part. The school hall is a fifth full after 8 minutes. So we need to calculate the sum, because remember, we're looking at the capacity, how many learners can sit in total, right? And they're saying it's only fifth full after 8 minutes. And you also have a rate at which the learners are entering. So let's work out S8 first. Sum to 8 terms. So what's the Sn formula? N over 2 into A plus L. Why I used A plus L? Because I have 38 here, okay? So remember, after the 8th minute, you have 38 learners here. Now Sn is S8 is equal to 8 over 2. A is the first term 10. Last term is 38. And that's going to give me 4 times 48, 192, right? Yeah, so we got 192 learners. Now remember, 192 learners makes up 1/5 of the capacity. It's only 1/5 full. Isn't that's what they're saying? So we can also use the ratios to solve this problem. Okay. So what is full capacity? It's just going to be 5 times 192, isn't? Because see, how we can use the ratios. Can use ratios like this, 1 over, yeah, you don't need to use ratios. We can say, we can say 1/5 of X, that's the total number of learners, is going to give me 192. So X is equal to 192 times 5. 192 times 5, right? 960. So the school health, this is full capacity, right? So what is the question asking us for? After how many minutes will the school hall be full? So we are looking at 960, which is SN, right? The full capacity. Remember, when you're calculating S8, it's the sum of all the numbers, so you're going to get 192. So this will be full capacity. So this is actually your SN. SN is, you can't use N over 2 into A plus L. You use N over 2 into A is 10 plus, let's write down the formula, 2A plus N minus 1D. And that must be equal to 960. You know what the value of A is? The value of A is equal to 10, and the value of D is equal to 4. Right? We know that. So we're going to put it inside here. Let's see if that is correct. A is 10. Common difference is 4. So N over 2, that is N over 2. 2 times A is 20 plus N minus 1. D is 4. Right? And that's equals to 960. I think you need to make a quadratic and solve here as well. So N over 2. So you can see 20, you're going to get minus 4 here. 20 minus 4 is 16. And N times 4 is 4N. Right, so now we're going to open everything up. So N over 2 times 4N is 2N squared. N over 2 times 16 is 8N minus 960 is equal to 0. We can still divide by 2. So N squared minus 4N minus 480 is equal to 0. All right, so N, and we have N is equal to 0. So mode 5, 3, 1, negative 4, and negative 480. Not negative 4, it's supposed to be positive 4. Go back, it's just 4. So I'm getting 20 and 24. Negative 24. Other way around. Right. So after The 20th minute, right? After how many minutes will the school hall be full? After the 20th minute. After the 20th minute. Right, so nice question. So you need to reject this. Time can't be negative. Okay, guys. Does that make sense? Mishka, we good?
Yes, sir.
Adolf, did that make sense? Right, so it's a nice question. This is also like a higher order question. I wouldn't say like level 4 because this is still manageable. You can still make sense of it. So that's where the trick was. It's only 1/5 of the full capacity. So what is the full capacity? Full capacity is X, and that's equals to 192. So the value of X is 960. So now you work with 960. Right. Nice, very nice problem. All right, so over here they have a quadratic sequence here. We can work with this. Still part of pattern, sequence, and series. Remember not to forget quadratics because they can also ask you that. Consider the following quadratic pattern 10, 21, 38. Determine the general term of the quadratic sequence. So you know what the formula looks like. So let's draw our tree. We got 10, 21, and 38. So there's your difference 1, and then your difference 2. So your difference 1 is 21 minus 10, which is 11. 38 minus 21, which is 17. And then the difference 2 will be 17 minus 11, which is 6. You remember the 3 formulas that we used to solve the quadratic. Right, so 2a is equal to d2, 3a plus b is equal to d1, and then a plus b plus c is equal to term 1. So 2a is equal to, let's solve this, 2a is equal to 6. So a is equal to 3. 3 times a is 9. 9 plus b is equal to d1, which is 11. You always choose the first values there, right? Left values. So b is equal to 2. Now a plus b is 3 plus 2, which is 5, plus c is equal to term 1, which is 10. So c is equal to 5. So what's your Tn formula? 3n squared plus 2n plus 5. Make sure to substitute a value. Let's substitute the number 1. So that works. Substitute the number 2, 12 plus 4 plus 5, 12 plus 9 is 21. It works. Determine the 10th term of the quadratic pattern. Straightforward. T10 is thus 300 plus 10 squared, right? Plus 25. So 325 plus 20 plus 5, basically. I wouldn't even do this, right? Just write down the answer 325. That's it. That's sufficient. Right? Determine which 2 consecutive terms of the quadratic sequence differ with 95, right? So now this is something I wanted to do. Uh-huh. Third one. I'm going to add one more question to this, all right? Now, obviously, you're going to continue the pattern, and they want to know there's a quadratic pattern here, right? And there's another quadratic pattern there. So the difference between these two, so if this is Qn, this will be Qn minus 1. The difference between these two quadratic patterns will give me a common difference of what? The common difference of differ with 95. So this value needs to be 95, right? Now think about this. What is Q2 minus Q1? It'll be term 1, right? So term 1 for difference. Look at the difference formula. So term 1 of difference 1, the linear part. Remember, difference 1 is a linear pattern. Difference 1 is a linear pattern. Now, if you take Q2 minus Q1, if you take the second quadratic and minus the first quadratic, you'll get term 1 of the difference 1. So now if I want Qn minus 1, I'm just going to get Tn here, right? No, I'll get Tn minus 1. 1 second. Yeah, so first we need to go and find this 95, which term it is, right? So just remember that. So the value of 95 is which term of this pattern. So the linear pattern over here is, let me move this to the side. Okay, no, it's fine. Let's keep this. What's the linear pattern here? The linear pattern over here is 11, 17, and so on. And we're going to end up with 95 there. So what's your Tn formula? Tn is A plus n minus 1d. So A is 11 plus n minus 1. What is d? 6. So 6 times n is 6n. Minus 6 plus 11 is plus 5. All right. Because that is 6n minus 6. Minus 6 plus 11 is plus 5. So 6n plus 5 must now be equal to, therefore, 6n plus 5 must now be equal to 95. So 95 minus 5 is 90, that is 6n. So therefore, n is equal to 15, 90 divided by 6. So 15th term of the linear pattern is 95. So this is term 15. So in the quadratic pattern, it will be 16, the difference between the 16th and the 17th term. So difference between 16th and 15th term is 95. All right. Difference between 16th and 15th term. So this has to be term 16. So remember what I wrote here. This implies I'm going to get quadratic 16 minus quadratic 15 will give me term 15. So see, we got n is equal to 15. That's the 15 term. 95 is the 15 term. So it has to be quadratic difference 16 and 15. Okay? Mishka, we good? You understanding?
Yes, sir.
Right. See, guys, when you do past paper problems, you always come across, new questions and stuff. And that's how you build your skills. You got to work with past papers as much as possible. Yeah, so that was Northwest Province. Northern Cape. How's the Northern Cape? Okay, I'm not going to do Northern Cape. That's in Afrikaans. All right. Let's look at Mpumalanga. Given the arithmetic pattern and term, sum of the sequence, write the sequence in sigma notation. Okay, I'm going to do it very quickly because we have covered problems like this. I want to focus on question 2.2 rather than focusing. Okay, let's just do this very quickly. Mpumalanga. Determine the nth term of the sequence. So Tn is equal to A, which is 181. What is this? Arithmetic. Plus N minus 1. What is D? Common difference. Ah, see how they have written this. Common difference is like this now. See, 181 is here. And they have reversed the pattern. It's written in reverse. So common difference is still 1 minus 5. All right. So 9 is going to be that last term minus the second last term, or 5 minus 9. It's minus 4. Common difference is minus 4. You can see you started from a very large number and you decreased it right until 1. So it is negative 4. So don't get confused there. So my Tn is negative 4 times n is negative 4n. Negative 4 times negative 1 is 4. 4 plus 181 is 185, right? Calculate the number of terms in the sequence. Number of terms in the sequence is, you're going to equate this to the last term. Okay? So you're going to equate this to the last term. So you're going to equate this formula for the second part. You're going to equate minus 4n plus 185 is equal to 1. It has to be equated to the last term, because the last term is 1. So negative 4n is equal to negative 184, 1 minus 185. 184 divided by 4, you're getting 46. N is equal to 46. So there are 46 terms. Calculate the sum of the series. You're going to calculate the sum of the series from 181 up to 13. How will we calculate this? Third part, just use a normal formula. Sn is equal to Sn is equal to, remember we're ending at 13, so we want to know how many terms are there first. Sn is equal to n over 2 into a plus l. A plus L. A plus L, correct. N over 2 into a plus L. We want to calculate how many terms are there. We don't know how many terms are there. But we can calculate it. See, if you go 1 back, you'll get 13. If you go 1 back, you'll get 17. 17, 13. You can minus 5 from here. So you have 41 terms. So you're calculating S41. 41 over 2. A is 181. Plus last term is 13. No. Sorry, not 41. You can have 40 terms. How many terms you're minusing? 1, 2, 3. Oh, we're only minusing 3 terms. From this total, we're only minusing 3 terms. So 43 terms, okay? Because we're summing up 13 as well. If you just go 1 back. 13 is part of this sequence, right? 43 over 2 into 13. But now if you don't want to do it like this and you check how many terms are there, you can also solve that. You can say solve the same formula equals to 13. You solve minus 4n plus 185 is equal to 13. N is equal to 13 minus 185 divided by 4. 13 minus 185 and then dividing it by negative 4. Getting 43 terms. Or you can just minus like what I did there. Right, so there's S43. You're just going to multiply this out inside here. So 43 over 2. Right, into 181 plus 13. I get 4171, right? And that's my final answer. 181 plus 13, 43 over 2. Yeah, n over 2 into a plus l. We have the first term, we have the last term. So we can use that formula. Now, write the series in 2.1.3 in sigma notation. So we know we have 43 terms. So S43 is equal to sigma. Look at the formula. Remember, when you're writing a sigma, is your TK formula, right? So in K equals 1 to N. All right. So now K equals 1 to 43. Right? We're summing up the first 43 terms. And what's TK? you need to change the n into k. So that's negative 4k plus 185. Now I will show you on the calculator that I will get the same thing if I type the sigma in. So shift sigma, negative 4 alpha x plus 185. Come down 1 to 43. You get 4171, same answer, right? So the sigma notation is correct. Okay, you can change the x to any variable you like. You can even change it to the calculator function, right? You can change the, but try to use k. Right, so I have written the same thing out here. That's fine. Nice problem. Write in sigma notation. Look at the next problem. I wanted you to focus on question. This question is on quadratic. The general term of a quadratic sequence is this, right? The general term of the quadratic sequence is an squared minus 5n plus c. It is given that term 4 is 18. Guys, when you're solving things like this, make a diagram, make a diagram. That's the best way to do it. And I would suggest that you always try to make a diagram and then solve. Don't sit and guess here because there's too many variables to consider. I'm not going to go right till the end, obviously. That's impractical, right? Those are your difference. And obviously the difference between these two will be the second difference, all right? Right, great. So this is what you're looking at. Centralize this a bit. All right, so let's see. This is what we are doing. Now let's fill in information. Term 4 is 18, right? Term 3 is term 2 plus 5. Calculate the values of A and C. Term 4 is 18, right? That's done. And then term 4, term 3 is term 2 plus 5. Term 3 here. Term 3 is term 2 plus 5. Term 2 plus 5. Term 2 plus 5 will give me term 3, right? Term 2 plus 5 will give me term 3. That's what they mean here. Because if you're looking at the other trees that we have done, how will you calculate 21? 10 plus 11 is 21. Right, so term 2 plus 5 is term 3. Right, great. We want to calculate A and C. Difference between term 3 terms. Calculate the values of A and C. The value of 5. What if we substitute it? Let's see. This diagram is not helping us at all. Okay. Since this is not helping us, I'm going to try another approach, right? Right, so we are talking about term 2, term 3, and term 4. So what's Tn? Tn is an squared. An squared minus 5n plus c. There's too many unknowns in this variable. See, in this diagram, there's too many unknowns. Term 2, term 3 is unknown. There's just 5 there. Not helping us. So that's why I'm using this approach now. Second approach. What's term 2? Term 2, substitute 2 here. What is term 2? Substitute 2 here. So that's 4a minus 10 plus c. What's term 3? 3 squared is 9. So 9a minus 15 plus c. Okay. What's term 4? N squared is 16a. 5 times 4 is 20 plus c. So now this makes sense. All right. So now we already know term 4 is 18. And now this is in terms of a and c. So this is equation 1. We can solve this. So you got 16a plus c is equal to 18 plus 20, which is 28, 38. So that's equation 1. Equation 2 is this one here. Term 3 is equal to term 2 plus 5. So what's term 3? 9a minus 15 plus c, right? It's actually term 3 plus term 2. So minus term 2. What's term 2? 4a minus 10 plus c is equal to 5. This is nice because the c's will cancel out when you eventually solve for a. So this is basically term 3 minus term 2 is equal to 5. So 9a minus 4a is 5a. Minus 15 plus 10 is plus 25, right? 9a minus 4a is 5a. Minus 15 plus 10 is minus 15 plus 10. Problem here. Let's just open up the whole thing. Otherwise, you can make mistakes. Right. 9a minus 4a is 5a. Minus 15 plus 10 is minus 5. C and C cancel out is equal to 5. So 5a is equal to 10. A is equal to 2. A is 2. Then 16 times A is 32 plus C is equal to 38. So the value of C is 6. So we got A as 2 and C is equal to 6. And that will be a nice way of solving it. I don't know why I did this. Right. So let's double check our answer. Let's substitute 4 inside this function now because A is 2. So 2 times 4 squared minus 5 times 4, right? Plus 6. Yeah, we're getting 18. So that is right. That's a nice question here for 5 marks. I wouldn't say it's level 4, it's like level 3 still. It's more like